How are you doing today? How's the homework going? Any questions, procedural or otherwise, about it?
So we're doing a Perl script?
Yes.
I didn't know people still use Perl.
I don't. We inherited the Perl script. Actually, people in the class, usually somebody rewrites it in Python and we give it to everybody. We could give you a Python script that was written, a port of the Perl script to Python that was written last year. If you think that would be helpful, we can't guarantee its correctness, but I don't know, who thinks that would be helpful? 2 people. Who thinks that would be unhelpful? So I'll see about that. I have to track it down. I'm not sure.
I think a better question is, has anyone here actually written Perl in the last 20 years?
So I've written Perl in the last 5 years, but not by choice. It's because I was working with somebody who likes Perl, which I consider to be a personality defect, but he seemed nice in other ways, so, it's hard to say. At least it's not PHP.
Yeah.
But yeah, if it was up to me, we would be doing everything in Haskell, but it's not up to me. So apparently we're doing everything in Python. So today we're going to talk about discourse and pragmatics. What is discourse in a general sense of the term? If you're talking about, he gave a lengthy discourse on the subject of why Perl is bad. What did he do? What makes it a discourse? Yes.
Like talk about it as if you're in a debate.
Okay, so it could be as if it's in a debate, but it doesn't have to be in the context of like a debate. Is a discourse just a collection of sentences? Or a collection of words? Yes?
Is it like a lengthy monologue?
So it could be a monologue. Usually when we talk about somebody delivering a lengthy discourse, we do mean a monologue. Although discourse in the general sense of the term doesn't necessarily imply monologue. It could be a dialogue or a conversation with multiple participants as well. Yes?
It implies like a certain extended amount of time spent talking about a single topic.
Okay, so there's a topic that's tying things together. There's some notion of a common meaning that is allowing the things that are said, the individual sentences, to cohere. Yes?
I don't know if this is relevant, but Michel Foucault has own theories about discourse and
Right.
transferring power in society based on language. I don't know.
Well, so Foucault uses discourse in a, and this is the way that literary theory kind of people use the word discourse, as this kind of hegemonic way of talking about things It's a little bit different sense of the word discourse, but that's if you have any friends who are English majors or sociology majors, I don't know what the chances of that are, but but if it were to happen, it's hypothetically possible. And they talk about I reject your patriarchal discourse. Anyway, then they're talking about discourse is in this kind of sort of textual ideology. And that's not quite the sense of discourse that we'll use in this class. Although there's sort of a spectrum. So the kind of computational discourse that we'll talk about relies a lot on what people have done in a field called discourse analysis, which is a field of that is in a way part of linguistics, but is allied also to other fields. And discourse analysis blends over into this kind of approach to discourse that you see manifest in people like Foucault, who's a French sociologist, in what is called critical discourse analysis. But we won't do that. That's not rigorous enough for us. Basically, amounts to a lot of opinionated statements about what other people have said, rather than things that we can nail down, which is what we're interested in. So discourse is coherent structure in language above the level of the sentence. So you've got sentences, and we've talked about how sentences have structure. What kind of structure do sentences have? What do we call it? Syntactic structure, syntax. And we might think, okay, you've got grammar up to the level of sentences. Above that, it's just chaos. You just throw sentences together at will. Sometimes it sort of feels like that, right? Some people sort of talk like that, too. What do we call people who talk like that, who just throw sentences together in a way where one sentence doesn't follow from the preceding sentence? What do we call people like that? We call them president. There is a structure to language above the level of sentences. And if we want to get language technologies right, we have to be cognizant of that level of structure. We have to pay attention to what is called coherence. And coherence, so when we say that that something is discourse, we mean that it is coherent at some level. That is, that there are meaningful connections between utterances. So what does that mean? How do you know that a discourse, that a text or a conversation is coherent? What distinguishes a coherent conversation from an incoherent conversation? Yes?
There are often references back to previous statements that were made.
Okay.
Sometimes in the form of pronouns, or sometimes in the form of referencing other stuff that's already said.
So this actually gets to a related kind of relationship that's called cohesion. So one thing that ties neighboring sentences together is that you have chains, what are called anaphora chains, where you have pronouns that are referring back to things in the preceding sentence, or words that are shared between two sentences. And these things show that they're about the same topic. So cohesion is an important aspect here. What else? Yes?
So I think the sentences we also have relationships to the physical objects and the actions on them. So I can say to someone that can you pass me the water?
Uh-huh.
So by the sentence the answer would be yes or no, but I'm actually ordering someone to or asking someone to pass me the water.
Right. Right. So this is an example that's often used when we discuss pragmatics. You know, that you have to know the discourse context in a lot of ways in order to interpret the sentence. And so this pragmatic information comes into establishing how that conversation is coherent. You know, yeah. We'll talk a little bit about that later in the lecture. Anything else? Yeah.
Maybe there's a central idea or a set of ideas, and the utterances lead through a flow of ideas.
Okay. So how could ideas flow? What kinds of ways could ideas flow? What are examples of relationships between ideas that could flow in a discourse? Yes.
I guess either like expanding an idea, like sentence one is like the fact, and then sentence two is like because whatever, or like.
So it can provide
making
evidence. You can provide evidence for a preceding fact, right? You could say it's because of this, or cause, or other kinds of elaboration. What else? What other kinds of relationships can you have? Yeah.
Sequences. So like if like you hear someone talking and they say like first this, and
Mhm.
they'll say something second this, and third.
So like temporal sequences. Yeah. What other kinds of relationships are there? Anything else? We'll see some more as we go along. Why is this relevant to us? What kinds of applications could you use discourse knowledge in? Here are some examples. So automatic essay grading. How would discourse knowledge about how discourses are structured, help you in performing this task? Yeah.
Maybe you can quantify coherence in an essay.
Yeah, and in fact, that's what automatic essay grading essentially does, for the most part, is quantifying coherence. So if you can quantify coherence, you can say, to some degree, how good an essay is. It's not an easy task, actually, but in like essay grading where they're on constrained topics typically, and there are limits imposed by the various constraints of the test-taking situation, then you can make it a tractable task. But yeah. So what about automatic summarization? How would knowing about discourse structure help you do text summarization? How does text summarization usually work? Does anybody know? Two kinds of text summarization. There's extractive summarization and abstractive summarization. Extractive summarization, how does that work? It's sort of what it sounds like. Yeah.
I think it finds the most important sentences,
Mm-hmm.
but I don't think it, like, I would guess abstractive creates new sentences.
Right. So extractive text summarization finds the most topical sentences, pulls them out, puts them together in some way, and calls them a summary. Abstractive text summarization finds the important central ideas and then generates language to express those ideas. So how would having a knowledge of discourse structure be relevant to either of these two forms of the text summarization task?
to find out which part is the most important, which sentence is the most important.
Right. So if you're trying to identify what sentences are most topical, what sentences have the essential information.
And I guess the way is to find out the sentence with the most link, with most linkage to the other sentence. I guess
Uh-huh.
that's how we. I'm
Well,
not sure how to
yeah, there are different ways of doing this, but there's something called discourse parsing, and you can take the the basically the sentences that sit higher up in the tree, and discard the stuff that's lower down, and that can give you like the essential sentences. What the baseline actually for extractive text summarization basically is to take the first sentence of each paragraph. So that actually works pretty well. Not very interesting, but it's actually pretty effective. So that's what you try to beat as a baseline. But if you have a knowledge of discourse structure, you can do better than that. And you can also make summaries that are more coherent, that don't just seem to be strings of important sentences from the article, but sentences that relate to one another. Let's get meaning understanding and talk about dialogue systems. Why is discourse important to dialogue systems? This is a very important topic right now. What would having an ability to deal with discourse structure do to help you build a better dialogue system? A dialogue system that's not lame like the dialogue systems we have now. Yes.
For one part, it would help you to kind of consider context rather than considering statements all independently.
Right.
So, like if you're talking to Alexa or Siri,
Right.
you don't have to like restate everything for it to understand what you mean. You can sort of give it in a sort of a conversant manner and reference things that you've already said, and it will understand.
Right. So Alexa and Siri have no memory and no like discourse context, and so you can't like use pronouns really to refer back to things from previous interactions. Really, Google Home is better in that regard. But you know, this is an example of applying a principle of discourse. You know, this idea of co-reference. You know, to dialogue systems. So, if you like Google Home better than Alexa, then you might like Discourse. Anyway. So there are different kinds of discourse analysis that are mentioned in your textbook. There's a chapter on discourse and there's a chapter on spoken dialogue systems. But there's kind of short-range and long-range discourse analysis. And deeper discourse analysis, you might say, is the real semantics. So if you say something like, John bought a car from Bill, Bill sold a car to John, they were both happy with the transaction. What about this, if you're trying to interpret this utterance, they were both happy with the transaction. What about that relies on discourse, on deeper semantics? What if you just took this out of context and said they were both happy with the transaction? Would that be a very meaningful sentence? If I just walk up to you someday and say, they were both happy with the transaction.
I will wonder who and what
Right, right, right. So this sounds actually like, as we'll mention in a bit, something my wife would say, because she does this. But normal people who are not members of her family don't say things like this out of context usually. Um, uh, they, this pronoun, and the transaction both indicate things that are what linguists call old information or discourse old information. So they should already be present in the discourse. When you put the before something, usually it means it's discourse old. And a pronoun also stands for something that's discourse old. So they should already have been introduced in the discourse. And getting that right requires a knowledge of discourse. But discourse is kind of like coming to the end of the sidewalk as far as NLP is concerned. In a lot of NLP tasks, right now you're doing part of speech tagging, right, for homework. So what is a good score for English part of speech tagging, accuracy score? What do you think? If you're doing this task with the state-of-the-art technology, lots of training data, instead of just one segment from Pentry Bank.
Accuracy?
Yeah, accuracy.
97.
Yeah, about 97%. Yeah. So what do you think is typical accuracy on discourse tasks, like discourse parsing, like if you were to try to identify all of the relations among different sentences in a discourse? What do you think is a good accuracy then? Like 30%. So F1, 30% F1. So this is, why would this be hard? Yeah.
I think it relies on a lot of background knowledge that people have.
Yeah.
And it might also be cultural background knowledge.
So we do a lot of this stuff. We use all kinds of knowledge to do this. We use knowledge about words, like about what verbs mean, for example. We use knowledge about the world. And this is knowledge that is not necessarily present in a corpus. And it's not necessarily something you could infer from a corpus. So having a lot of training data doesn't necessarily solve this problem for you. And you're dealing with, basically, in order to do discourse, you have to have syntax down. But in order to do syntax, and you have to have semantics down. In order to do semantics, you have to have syntax down. In order to have syntax, you have to have morphology down to some extent. In order to do morphology, you have to have the lexicon under control. And so there's this stack effect, where if something is wrong earlier in the stack, then the errors propagate. So it becomes very difficult to do this. Even if you have some neural architecture where you're doing end-to-end kinds of things, you still have this problem. That you have lots of levels of structure, and so it's hard. It takes you to the sidewalk's end. So coherence, as we mentioned, is about having meaningful relationships between sentences. So you can have a discourse, you could say, John Hill hid Bill's car keys, he was drunk. Is this coherent? So how do these two sentences relate? What is the second sentence to the first sentence? Yeah.
Expand and give more information on you than like John would do. At that time, like if you know John's going to maybe it justifies his action if you know Bill was going to kind of
Yeah, so potentially it could be either John or Bill who is drunk. But probably, if we use our world knowledge, then probably it's who is drunk? Probably. Probably Bill. Bill is trying to help John by hiding his car keys so he doesn't drive drunk and die or kill others. And so he was drunk. Does what?
What is the motivation for the action?
Yeah, so it explains why this is true. Explanation for this. So what about John hid Bill's car keys? He likes spinach. What's wrong with this? Is it because he likes spinach? I like spinach. There's nothing wrong with me. What is wrong here?
Using the common knowledge, you couldn't find a link between it.
It's hard to find a link between these, right? Using our world knowledge, it's hard to say how liking spinach has anything to do with hiding car keys. So this is not coherent. So coherence contrasts with another relation that we'll call cohesion. So coherence is the question, is there a meaningful relation between sentence A and sentence B? Cohesion asks, how closely related are sentence A and sentence B? How close do they cluster together? And these are related concepts, but they're different, and it's important to keep them separate because there will be a test question that asks you to distinguish cohesion from coherence. Okay? So cohesion, there are different things that help tie sentences together, and we've already discussed some of these. But what adds to the degree to which two sentences stick together? Or in other words, what are linguistic signs that two sentences are on the same topic? What do you think? Yes.
You have common words.
So they have common lexical items. So that's an important thing. So they have lexical items in common. What else? Yes.
You say that the ratio of whole knowledge over the total knowledge is higher.
The what?
The ratio of whole knowledge over the total amount of knowledge is higher for cohesion. So we have many common references.
Oh, okay. So common references for cohesion. Because right now we're talking about cohesion rather than coherence. So for cohesion, yeah. So if you have shared references, if you have one sentence referring back to the previous sentence, like with pronouns, for example, then you have a greater degree of cohesion. So here, where we have John in this sentence, and then you have the pronoun he that refers back to that, and he that refers back to that one, and he that refers back to that he. This is what is called an anaphora chain. And if you have lots of anaphora chains within a span of text, that's a feature that we can use, that we can train a model on to detect a high degree of cohesion that we can then use to segment text together. So here you have John went to the store to buy a piano. It was the store he had gone to for many years. You do have it referring back to the store. He was excited that he could finally afford a piano. Refers clear back to John, but it doesn't refer to anything in this preceding sentence. So there's a kind of lapse in cohesion as expressed through an aphora change. In both of these cases, you have piano in a couple of different sentences, which lends to cohesion, although they're not necessarily in neighboring sentences. But that's because in the span, and in this span you have piano in both spans, you have a relatively higher cohesion. And store as well. Store. But what about coherence? Which of these is more coherent? So cohesion is about the sentences sticking together and being on the same topic. Coherence is about there being a meaningful relationship between the sentences. Which would you say is more coherent? Which one? You think the bottom one? Does everybody agree that it's the bottom one? Yes. You think they're equally coherent? Yes.
I think the first one's more coherent because the subject of the sentences is all about.
Uh-huh.
Whereas the second part of the sentences comes between the story.
Okay. So in a way that is cohesion rather than coherence because it's about the topic. This is about John, or this is about John and the story. But they're both fairly coherent, actually. In fact, they should be equally coherent because these we're simply restructuring these sentences in such a way that the subject is a different pronoun. So this shows how cohesion and coherence are different. Let's talk more about cohesion. Yes.
Are there any difference in terms of cohesion between the two sentences? Like for example,
These sentences?
are there any difference in terms of cohesion?
Yeah. So there's higher cohesion here because you have an anaphora chain that goes through the whole thing. It ties all of the subjects together. They all refer to one entity. Here, you have smaller anaphora chains. You have it referring to store, and then John and he, but they're not. And here you have store in all but one of the sentences, so you have higher lexical cohesion. Well, piano in two sentences. You have piano in two sentences, and store in two sentences. So these have a relatively high cohesion. These might, but this kind of gets left out. So this is definitely there's definitely higher cohesion here than here. So the reason cohesion is important is sometimes we want to segment text into by topic, basically. We want to take a text that's given to us and essentially divide it into paragraphs. Why would we want to do this? Why might this be valuable or interesting? Can you think of any application? Yes.
Well, if we, for example, maybe had a document and a question about the document,
Uh-huh.
we could potentially segment the document into a sequence of subtopics, and then we could like compute similarity between the question and the different subtopics within the document to see which.
Yes, hypothetically.
Yeah.
Yeah. So that is actually an application people use text segmentation for. What was your?
I was gonna say it just makes it easier to search, not in terms of like a computation and just like
Okay. So what if you're doing ASR, you're doing speech to text, and you're taking like radio broadcasts or long speeches, and you want some kind of meaningful segmentation of what those people are saying into something like paragraphs, that this is a way that you could do that, for example. It's also important to text summarization and so on. So news stories make this somewhat easy. Has anybody here ever written a news story? Has anyone here ever read a news story? Who's here's read a news story? Yeah. So if you notice, all news stories are kind of the same. Who's noticed this? Yeah. Boring, right? They're all the same. No, they all start off with the most noteworthy information. Then they give details. Then they give other information and background information. Why are they structured this way? I mean, that's not necessarily how a magazine article is structured or how a book is structured. Why would news articles be structured that way? Yeah. Yeah, so that's part of it. So you can get the most important thing just by reading the first paragraph. There's another reason, though, which is that it has to do with editing of newspapers. And there's a certain only so much space to be filled up, but you've got to fill up the space exactly. So you write the article so that you can cut it off at any point, and still have a coherent discourse, basically. So that you follow this kind of structure where you put the most important stuff first, and then the less important stuff. It gets less important as you go down. So how would you segment discourse? Let's say you have some features for cohesion. What kind of features for cohesion have we talked about? So an afrochains and okay, so we didn't talk about this, but that's actually an important one. Discourse markers, like conjunctions and adverbs that tell you there's a relationship between two sentences. And what is the third one? So lexical coherence, or whether they share words or synonyms or hypernyms. Okay, so you've got those features. Let's say you have those features for every sentence in your corpus, or every sentence in your document, and you want to segment your document. Let's actually say that rather than doing it by sentence, you do what people who do this actually do, which is divide it into pseudo sentences of like 20 words. So you've got this list of pseudo sentences. You've extracted all the features. Then you want to figure out how to divide it into into segments. What are you going to do? Yes.
So the idea is you could just follow in an after chain until it ends,
Mm-hmm.
or you could also like approximate like lexical similarity boundaries by just sort of like clustering, like finding clusters and find sort of a cutoff where they're where there's the biggest sort of jump
Right.
or break in similarity.
Yeah. So couldn't you like take these features and put them in a vector? So you have a vector for each pseudo sentence, part of which gives you the anaphora information, part of which gives you the lexical information, part of which gives you, the presence of discourse markers.
Connection to the preceding sentence, or
Yeah, with connection to the preceding sentence. Right. Well, let's talk about this in a different way. So you can take the lexical thing, and you can basically do bag of words with it. So you can have vectors, and for the lexical cohesion, you can use cosine similarity and compute the similarity between each successive sentence. And then for this, you look for dips. For anaphora chains, you could do something similar in the sense that you can look for how many anaphora chains cross between a pair of sentences, continue between a pair of sentences. And so you look for dips in that, you look for gaps. And for discourse markers, then a way of looking at it is if you have a particular discourse marker that marks the beginning of like a paragraph, then this is tick off. But if you have one that signals a relationship between two sentences, a close relationship or a continuation of the topic, then that bumps you up. And so you go through and you look for the valleys, right? So there are two different ways of doing this. One way is to just set a threshold and say if you go below this threshold, then it's a separate, then there's a boundary here. What is the other way? Yes.
you could say I want to break it up into n segments and then just sort of find what usually do that number of segments.
Right. You can do divisive clustering, right? So you identify the number, k. I want k segments, and then you do divisive clustering, and you get k segments. There's k segments that most closely relate to one another. That's what people do mostly now when they do this. So let's talk about coherence. So let's look at this piece of discourse here. So John went to the bank to deposit his paycheck. He then took a bus to Bill's car dealership. He needed to buy a car. The company he works for now isn't near a bus line. He also wanted to talk with Bill about the soccer league. Is this coherent? It's pretty coherent. You can there's a relationship. Each of the sentences relates in some way to the rest of the discourse. But you illustrate a number of different relations. And so basically, here you have the relations, and you have the sentences that are in the relations. So you have an occasion. So S1 is an occasion for the rest of these. So this node dominates all of these other nodes. So the rest of this, you have an occasion, and then the rest of it is an explanation for why John went to the bank to deposit his paycheck. S2, so you have S2 as an explanation, and you have an explanation that's the relationship between S2 and the rest of this. And so on down the tree, basically. So it's basically taking a discourse and giving a tree structure to it, where you have the relations here, explanation, parallel, explanation, and the individual sentences or utterances here as leaf nodes. So here are some examples of coherence relations that are sometimes used, although we'll talk about a larger group of these in a moment. So one is explanation. So this is where we infer that the state or event asserted by S1 causes or could cause the state or event asserted by S0, which is not to be confused with occasion, which is a change of state that can be inferred from the assertion of S0, whose final state can be inferred from S1 or vice versa. And then parallel, which is basically there's a similarity between the two utterances, and the assertion of S0 well, anyway. So there's a more explicit theory of coherence than this one, and that's what's called rhetorical structure theory. And one way of understanding this is to relate it to dependency grammar. So in dependency grammar, what are the relationships between, what are the entities that are related, and what are the relationships between them? If we think back to when we were doing syntax, you have to know this for the exam, so it's good to remember it now.
For example, subject and object are related by a verb.
Well, kind of. So a verb is related to its subject, and that relationship is a dependency. So a subject depends on a verb. So a verb is the head, it's the important one, and then the subject and the object depend on the verb. So it's dependencies among words. In rhetorical structure theory, you have basically dependencies between sentences, and you have more important or head sentences that are called nuclei. And on these depend more peripheral sentences that are called satellites. Then you have relations that are the arcs that connect them. And something, so you have a top-level nucleus, and something can depend on it as a satellite, but can then be the nucleus of another relation. So the definitions of relations make reference to the notions of reader or writer. So the idea is that you have a person who's producing the discourse, and he or she is trying to do something to the person who is reading the discourse, is trying to affect what they believe or what they do or what they think in some way. And that's why it's rhetorical structure theory. And so the definitions are stated in terms of reader and writer. So here's an example of an RST tree. So this is from, I think, Scientific American about Mars. This is somewhat outdated, but it's in the textbook, so I kept it here. So basically, you start off with, you have the main nucleus here. And it's not the first thing in the discourse. But it's the most important thing. So you start off with this background that depends on the nucleus here, the main nucleus. And then you have evidence for this main idea that Mars experiences frigid weather conditions that depends, so all of this is evidence. And it depends on that number 3, Mars experiences frigid weather conditions. And you have different relationships between these subparts of this evidence, the stuff that's in the evidence relation. So one thing is elaboration. So all of this from 6 to 9 is elaboration of the ideas that are in 4 and 5, which is a list that talks about the temperatures on Mars. So this is how rhetorical structure theory basically works. And there's a big rhetorical structure theory tree bank. One problem is there are a huge number of these relations. So there are like 70 of them in the RST tree bank. Is that a problem? So suppose that the distribution of these relations is basically zip field. What problems do you foresee? So you got like 70 relations. 30 of which are fairly common. Yeah.
Or other 40. If it really is a zip field distribution, then the other 40, especially on the lower end, are
really uncommon.
So you need a huge training set.
Yeah. So it's a reasonable sized tree bank, but this is hard annotation to do, so it's not that big. And so if you're trying to train off of it, there's going to be this long tail of things that you may not have seen before, or you haven't seen enough examples of, that you can actually identify them. So it's hard. And if I was doing this, I think I would try to have fewer relations, fewer, more general relations, but I'm not. So here's an example of what a relation and RST looks like formally. So if you have the evidence relation, you have N for nucleus, S for satellite, R for reader, and W for writer, then you have a constraint on the nucleus. That for the nucleus, the reader does not believe the nucleus enough for the writer. The writer would like the reader to believe the nucleus more. You have a constraint on the satellite, which is that the reader believes the satellite, or would if presented with it. And then a constraint on both N and S, that the reader's believing in S would increase R. So in other words, that S would be evidence for R of N. And it would have the effect that R's belief of N would be increased, or it should have that effect. So that's what an evidence relation looks like. And all of the relations are defined in this formal sort of way. So you should be able to have reasonable intercoder reliability, when you're annotating these things, and it should be ultimately learnable as well. But what would make this challenging to learn? Something we've talked about before. Are you just scratching your ear? Yeah. It's okay. You're allowed to scratch your ear once. What would make this hard? Yes.
I guess like it's just really hard to interpret and believe something enough for like would believe.
Yeah.
The
How
choice
do you
of belief.
how do you know whether someone would believe something if presented with a particular piece of evidence? So you might have some idea what people would know. How would you make a computer program know that? Or behave as if it had such knowledge? Not easy. So one task that is relevant here is automatic coherence assignment. And basically, if we have a set of sentences or clauses, then we want to automatically determine the coherence relationship between them, which is coherence relationship assignment, and ideally extract a tree or a graph that represents the whole discourse. And that's what we call discourse parsing. So this is very hard. Nobody has a good way of doing this. If you find a good way of doing this, you'll be rich and famous. People will love you. People will want to have their picture taken with you at conferences, which I think is your dream. So keep working on it and figure out a way to do this. Right now, what people do basically is they look at discourse markers. They use discourse markers as features. Words like because and similarly. These cue phrases, this slide says. Use these to segment the text into discourse segments, and then use a classifier to classify the relationship between each consecutive discourse sentence based on a variety of different features. Use of discourse markers is really important in this so far. And use of abduction or defeasible inference is also important for the world knowledge part of this. So abduction is the kind of reasoning that says all men are mortal, Max was immortal, maybe Max was a man. So it's defeasible. It's not. You could be wrong, but people use abduction all the time. That's a kind of approach that people use, this kind of abductive reasoning, in dealing with the world knowledge aspects of coherence assignment. So let's talk now in the remaining amount of time about pragmatics. Has anybody here heard of pragmatics before? We talked a little bit about pragmatics earlier. What is your name? Soda? So you brought up an example about, could you pass the, what was your example? And how did you say? Can I have a glass of water? Well, yes, you can have a glass of water. I mean, if we interpret that according to its semantics, then it's a question, and so we'll give an answer. You know, it's a kind of question that calls for a yes/no answer. But that's not really what you mean, right? You don't really mean, is it possible for me to have a glass of water? You want a glass of water. I also want a glass of water, because I'm about to cough. That is what pragmatics is all about. You know, so we go beyond semantics to the meaning of language in context and how you do things with words. So here's an example of a pragmatic difference. This is something that's attributed to everybody, but it's the statement, when a diplomat says yes, he means perhaps, and when he says perhaps, he means no, and when he says no, he's not a diplomat. What is this all about? What is the point of this? So the diplomats are liars? It's part of the Soros-occupied State Department. Anyway, just kidding. Anyway. Yes?
It's what to do with intention.
Yeah.
In the sense you say, can I have a glass of water? Your intention is to ask someone to have a glass of water.
Uh-huh.
And your
So what you're trying to do
is
with the other.
is like this guy is it's not in the exact same words. You're not placing the exact same words as it is in your head.
Uh-huh. So why would people do that? Do people do this commonly, or is this a marginal sort of thing? Pretty common. So can you think of other examples where in a particular context or coming from a particular person, an utterance has a different meaning than would be suggested by its semantic value?
Sarcasm?
Okay, sarcasm and irony, right? Irony. Well, can you give an example? That certainly was an interesting lecture. I knew that's what you were going to say. That's why I said it for you. Yeah, so people do this all the time. But what they mean is the opposite of what they say. How do we make machines understand that? What would it take to make a machine deal with irony, including sarcastic irony?
would say in that case the coherence will go down, given the context.
So it can look like coherence is going down. And if you find something that looks like it's incoherent in a discourse, then that might be a reason that might boost its probability of having a meaning in its context other than its semantic content. Right? Yeah.
This might be easier when dealing with speech rather than text.
Uh-huh.
Because, for example, it's a lot harder to detect sarcasm over text messaging than it is like if you're talking to somebody. So like tone and inflection of speech is sort of a big factor in that, or it can be.
Yeah.
Yeah.
Yeah, that I've noticed that people don't get. Particularly, I've noticed this with my parents. They don't get irony over text messages. Anyway, it's caused some unfortunate awkwardness. But anyway, yeah. So there are cues that you can get from speech, intonational cues and so on, that let you know, oh, this is not. What this means is different than what the words are saying. So what kinds of contexts could we have for language that would influence what language means? Well, some are listed here. So social context. Social context ever influence how you interpret language? How? Yes.
I think going back to the irony example, like I have certain friends who have like a greater tendency to be sarcastic or ironic, and others who tend to not. And so like depending on the person I talk to, if they're generally more sarcastic, it's more likely that what they're saying is like.
Right, and probably they fall into different social groups too. So there's some people with particular identity that's constructed around being ironic. They're going to use more irony than somebody who has a social identity that's constructed around earnestness and so on. So, what about physical context? Linguistic context? Anything else in context? How does this influence how we interpret language? And how does this present problems for speech and language technologies? Yes?
I think there's a big problem, like how do you represent context, and how do you represent different kinds of context, and how do you determine like which types of context are most relevant. And so like how would you map, maybe historical context versus social context versus, linguistic context, and how to take different parts of the sentence and understand which parts map to which areas of context. That seems like a very difficult problem.
Yeah, it is a difficult. Just the representational part of the problem is quite difficult. And once you've overcome that, there are still other problems. What other problems remain once you have, suppose you had a good way of representing all of these kinds of contexts. Yes. Yeah. And you have to have a very rich kind of training data, right? And so this is an enormous challenge. so, if you can get, if you really want to pass the Turing test, and I know that after getting your pictures taken with people at conferences because you have solved Discourse, that your next major goal is to write a intelligent agent that passes the Turing test 100% of the time. If you're going to do this, what is your bot going to have to know about pragmatics? And how are you going to give it that knowledge?
Put it on everyone's phone and have it listen to everyone's conversation.
It's a government solution, but yeah, you need a lot of data, and you need to be able to. But really, would just listening to their conversations be enough? Why do you need something more than just listening to their conversations?
Use some sort of evaluation, like a label.
You need either labels or you need some kind of supervision or even distant supervision. Uh-huh. So we probably need representations of things other than just language, right? So maybe rather than just recording everybody's phone conversations, we follow them around with a camera. So we have cameras set up everywhere to watch them and see what they're seeing when they, we need richer data, multimodal data, really, in order to do this effectively.
I think like if you could do like a neural implant into someone like surreptitiously while sleeping or something.
Yeah, something like that.
Yeah.
That's what I'm thinking.
I just question. Does the machine really learn such things for the pragmatic? It's a problem because it wants some information not from the word, but from the relation between the words, or from the knowledge behind those words. And what makes the words more complicated is those knowledge are not even universe. It's like a region-based or country-based. Some universe within the whole human society. It's not a common knowledge between humans.
Right.
So the question about is that really a kind of ability, or is just a kind of a dictionary, some kind of dictionary. So each the people in each country has their own dictionary when it hit the keyword, and some maybe irony, some things trigger. That's how I think. Is that really ability, or just some kind of dictionary fixed things?
So I don't quite follow what you're saying, but are you saying that on a culture by culture basis, maybe there's a knowledge representation, a knowledge base that people within that culture have, and they're just relying on that knowledge base rather than some general ability? Right. But somehow people learn what is in their knowledge base, right? Humans do it. If humans do it, then I don't want to be too flippant in saying this, but machines surely can do it. I mean, if we're computational devices, essentially, then if our cognition, if human cognition is computational, and if we could model what happens in a human brain in a computer, then we should be able to do what a human brain can with a computer. Anyway, so I've disclosed my position on strong AI. So, so we should be able to get computers to do this, to learn that knowledge base, for a particular culture, for a particular context. The question is, how do we do that, and is it feasible? What do you think? Who thinks that within their lifetime we will have computers that consistently understand sarcasm? Who thinks that within their lifetime we'll have computers that can correctly respond to arbitrary polite requests? Who doesn't think either of those things is true? It's okay if you don't. So is this not a hard problem then? Because not everybody who voted in favor of. Yes.
Well, one observation I have is like it takes humans quite a while to learn this,
Mm-hmm.
like years. And
Small children are not great with irony.
so
I've
like
noticed.
As far as I know, nobody has had something sitting around interacting with humans for years trying to learn this stuff. I don't know, maybe they have, but it seems like maybe given enough time, if a single system were given enough time in an environment with a bunch of humans doing all these interactions, maybe it could, but it's I don't know.
Yeah.
But the thing is about that is that you're limited to only like one interaction at a time. The computer could train on thousands of interactions, just like in a moment, right? Using previous interactions. So you could possibly get like years of experience very quickly.
Yeah, so you could get a lot of interactions, a lot of experience. So if you structured things right, then you could do this. If you have the right data in the right quantities. So those are things to think about. I'm looking forward to revolutionizing the world, and I hope someday to get my picture taken with one or more of you at a conference because you're famous. If you have any questions, post on Piazza. There are some more slides in this deck. You will be responsible primarily for the parts that we've covered. There are other things on speech acts. There'll probably be one test question on speech acts, so you should review those parts of the slides. But the central themes that we want you to understand are discourse and pragmatics as in the basic sense. So have fun, and I'll see you later. See you Thursday again.